Hello pre-calculus students, and welcome to the third video of 9 on half-angle formulas. So we're almost at the half-angle formulas, or identities as they're often called. Let's take a look at what we've done so far and kind of where we are in the process. So here's, we started out in the last unit with the sum and difference formulas. Then we pretty much said if alpha equals beta and we used the sum formulas, we got to the double angle formulas, or identities. And then from there, we just used these cosine identities, these two variations of the cosine identities, to create a sine and a cosine power reducing identity. And then we used the definition of the tangent to put the sine squared over the cosine squared, and it reduced. Okay. Now, if you look at the power reducing identities, and you look at the half-angle identities, let's just take a quick look, because there's a lot in common here. I want you to kind of see where we're going before we start actually doing it. So if you look at the sine squared power reducing formula, and then you look at the sine of theta over 2, you can kind of see, like, taking this and taking the square root of both sides will kind of lead to this, except for the arguments being a little bit off. And this is theta over 2, this is 2 theta, and this is just theta. So you can kind of predict what's going to happen there. And let's go ahead and show how this gets fully developed here. So this is the power, so we're going to go from power reducing identities, which we have here. These are the two that we, for sine and cosine, that we have in the last video. And we're going to go from there, and basically all we're going to do is what it says right here. We're going to start with the power reducing formulas, and then we're going to replace theta with alpha over 2. So it doesn't really matter what the angle is called, it's still just an angle. If theta were a 70-degree angle, and it worked for 70 and it works for all angles, then it would also work for 35. So there's no reason why you can't cut it in half and still have an identity work. So we're going to do that for our first step. We're going to replace theta with alpha over 2. So we're going to call this one the sine squared of alpha over 2 is equal to 1 minus the cosine of 2 times alpha over 2, all over 2. Okay, so the sine squared of alpha over 2 won't change, but the other side is going to get a little nicer. 1 minus the cosine of alpha, because 2 times alpha over 2 is alpha. Okay, and that's still over 2. And now we're going to take the square root of both sides, so we get the sine of alpha over 2 is equal to plus or minus the square root 1 minus the cosine of alpha over 2. And there's the first half-angle identity. Okay, we'll do the same thing. I'm going to pause the video and do the same thing with the cosine square. Let you guys try it first. Okay, so there's the cosine of alpha over 2. You can see the plus or minus. Now, before we get into this, for the tangent directions here, there's actually 3 tangent formulas. And if you look at the main page of identities, you see only 2 are shown here. But depends on where you look. There actually is a third one, so we're just going to the third one is really easy to come up with. So our tangent formula, or identity that we already have, is the tangent squared of theta is equal to 1 minus the cosine of 2 theta over 1 plus the cosine of 2 theta. And I'm just going to check that. Here it is 1 minus over 1 plus, so yeah. And then we would just take the square root, replace the half angle, and we would end up with the tangent of alpha over 2 is equal to plus or minus the square root of 1 minus the cosine of alpha over 1 plus the cosine of alpha. But the thing is that we really don't like this plus or minus, and you'll see why when we start to solve problems. It's just another step that adds some challenge to a problem, just another step that we don't really need to do, because we actually have a couple of other alternative formulas for the tangent. So I'm just going to show you really quick where those come from. So for the tangent formulas that are that are easier to use, that don't have that plus or minus, we start with the power reducing formula, sine squared of theta is equal to 1 minus cosine of 2 theta over 2, and the double angle formula. We're going to put these two things together, and we're going to replace thetas with all the thetas with alpha over 2. So we end up with two formulas. Sine squared of alpha over 2 equals 1 minus the cosine of alpha when I multiply it by 2. Okay, that's the first one. And then we also have the sine of 2 theta, which we're going to replace theta with alpha over 2. We're just going to get the sine of alpha is equal to 2 sine of alpha over 2 times the cosine of alpha over 2. I just like to put those in parentheses to make sure we know everything's being multiplied here. Okay, so first I'm just going to rewrite this first formula here by multiplying both sides of the equation by 2. So I get 2 sine squared of alpha over 2 is equal to 1 minus the cosine of alpha. Okay, now if these two equations are both true, they're both identities, they're both true for all inputs, then we should be able to divide one by the other, and it's dividing by something that's the same also. So we're going to basically write 1 minus the cosine of alpha, that side of this equation divided by this side, so divided by the sine of alpha. And just one of those many tricks that mathematicians do to come up with easier ways to do things. So the other numerator would have to be this one, so it's going to be 2 sine squared of alpha over 2 sine alpha over 2 cosine alpha over 2. The 2's cancel. This is supposed to cancel right here, but I forgot to include the alpha over 2, so right here, this alpha over 2 right here, is supposed to be here also. So now we have the same thing, sine squared over the sine of the same angle. Let me bring that back. And so one of these cancels with this whole thing. So now we have 1 minus the cosine of alpha over the sine of alpha equals the sine of alpha over 2 divided by the cosine of alpha over 2, which is the tangent of alpha over 2. So we can rewrite this as one of our alternative identities as the tangent of alpha over 2 is equal to 1 minus the cosine of alpha over the sine of alpha. And that's one of the easier to use because it doesn't have that plus or minus like the tangent of alpha over 2 has over here. It doesn't have that. But the other one, I'm just going to show it to you without deriving it. It pretty much derived this very similar way. The other one is right here, and you just need to be able to refer to them, and the next thing we're going to do is learn how to use these. Okay, hope you found this video helpful.